Hello guys, welcome to TUTORIEX. And this is my 10th video and I'll talk about operators here. And from the last two videos I'm talking about operators. So let's go to the beginning. So from the last two videos I talked about these arithmetic operators, assignment operators, comparison operators, logical operators, identity operators. And this video I'll just finish this topic by membership and bitwise operator. So let's just go where we ended in membership. So in operator, right? So how in operator works, it's gonna verify that if an element is inside a list or not. Inside a list, it can be list, it can be tuple, it can be dictionary. I know I haven't discussed any of this yet in my playlist, but I'll gonna discuss it later. So at first what I'll gonna do is I'll gonna make a list here. I know I haven't discussed list yet, but just think of it as a variable which stores multiple data at the same time. So you write it by third bracket. I'm gonna make a list of integers like 12, 45, 8, 90, 45, 49, 76, like that. And this is a list. So list, you see there's a list, just take it, I'll explain it further later. So what you do is you check if an element is inside a list or not. So you write like 12 in nums. So let me see, is 12 inside the list nums? Of course it is, it's the first character. So just let me run, it's gonna say true. And let me make another list. I'm gonna check, is 99 in nums? Is there a 99 you can see? Of course not, so it's gonna give false. And not in is same as this in, but just works opposite. So I'm gonna copy paste this list here, run this, and if I say 12 not in nums, so 12 is in nums, right? So 12 not in nums, it's not true, so it's false, so it's gonna give false. And if I say 99 not in nums, of course 99 not in nums, so it's a true statement. Just think it as a simple English statement, so it's true. Bitwise operator, so most important thing about bitwise operator is you have to know about binary numbers. And if you don't know about binary numbers, it's just leave it here. And if you know about binary numbers, I'll just gonna explain it in short. So first it comes AND operator. So what AND operator does is, like, there's a rule. This is the three rules how AND operator works. If every digit is 1, then the output is 1, and if any digit is 0, any bit is 0, then the whole output comes 0. So let me give this example here. It's not the syntax, I'm just giving example. See, last digit 0 and 1. So 0 and 1 is 0. 1 and 1, 1. 0 and 0, 0. 1 and 1, 1. So what is the result? 1 0 1 0. So 1 0 1 0 is, if you convert it to decimal, it's 10. So how you do it? 10 and 11. So if I press enter, it's 10. You see the result. That's equals to 10 in decimal. If you know binary decimal, I hope you understand. Now there's a bitwise OR operator. So I'll just copy paste it here, the rules. So that's the rules. So there's few changes here. Unlike that AND operator, OR operator is if any of the bit is 1, the whole output is 1. So here it will be 1 and 0. So this 1 there, so whole output is gonna be 1. And if it's 1 and 1, of course it's 1. And if it's 0 and 0, so it's 0. So what do you think is gonna happen here? So if I'm using OR operators, so last digit 0 and 1, it's a 1. 1 and 1, it's a 1. 0 and 0, 0. 1 and 1, 1. So what's happening? 1 0 1 1. That if you convert it to decimal, it's 11. So let me see what happened. So it's 11. 10 or 11 is 11. So that's how it works. And bitwise NOT operator, a equals to 10, and after that you give the squiggly sign here, then put a, and output it's minus 11. So there's a formula how it works. Like you put a minus, you first convert it to binary, and we saw earlier 1010 is the binary form of 10, and you put is the formula. You put minus here and you put the binary and you do +1, so it's happening minus of 1011, that is -11. See, that's the output. So that's how it works in simple. And there's left shift right shift operator. So there's an example I wrote here for you. A = 5. If you convert 5 to binary, it gives 0101, and I took it as 8-bit binary. See, 1 2 3 4 5 6 7 8, it's 8-bit binary. So what's happening is I put 40 extra here, 101, that's binary form. So I'm gonna left shift it, left shift. You see the arrows, left shift. So what's happening, see carefully, 0000, it's intact. 1 is shifting here, see, 1 is shifting 1 bit left, then this 0 is shifting 1 bit left here, this one is shifting 1 bit left here, and at the last 1 extra 0 is added. So 1010 is 10, we saw it from earlier. That's how it works. I'm gonna show you in example. So A, right shift 1 bit, 10, right? And if you shift 2 bits, look here, it's already shifted 1 bit, and next bit if you're shifting, if you work with this, A = 2. So shifting like that, you do like 0001, right? Because this one is shifting here and this 0 is shifting here. So just look it carefully, shifting 1 bit to the left. So it's happening 10100. That's, if you convert it into decimal, that's 20. That's how it works actually. So if I, instead of 1, I press 2, so it's 20. Same here, the left shift works. So I'll copy here the example, and you're gonna get this all notes in in the description. You're gonna get all of this. So A = 5, I'm gonna take the same example, right? And instead of left shift, I'm gonna do right shift. So 1 bit to the right, so this 0 goes here. So here it's already 0, and this 0 goes here, and this one goes on the second place, and last one goes out, so there's no position here. So 0010, that's 2 in binary, in decimal. And if you shift 2 bits, you see this 1 is gonna come here and everything is 0. So everything is 0, and this 1 which is in the second place is gonna come in the first place. So it's 0 here and only 1. So 00000001, that's, if you convert it to decimal, it's 1. So that's our example, and we're gonna write it in code. A = 5, A, right shift 1 times, it's gonna give 2, and if you do 2 times, it's 1. So that's how it works. Hope you get that. And this is the end of operators, and in next video we'll talk about list in Python. So see you on the next video. Bye bye.